Hello, and welcome to today's daily Leetcode challenge in Rust. Today I'll be going over question 2009, minimum number of operations to make array continuous. Just for all of you to know, the more thorough and the drawn out explanation, I have a Python video on because that's usually how I operate. I usually have the logic implemented in Python and then I simply rewrite it in Rust. It's just easier that way. Uh, and so I'll only sum up the solution here. The idea is we want to figure out how many values do we have to replace um, given that we have this nums array to treat these two properties, to have these two properties be true. And these two conditions are essentially claiming or restricting us to only have a continuous array, as in like 1, 2, 3, 4, without any breaks, right? Cool. It makes sense. So given that we have an array, something like 1, 2, 3, 5, 6, it's clear that we're skipping the number 4. We can't have that. So we either have to convert 1 to a 4 or convert 6 to a 4. And we would then be left with either 1, 2, 3, 4, 5 or 2, 3, 4, 5, 6. Awesome. Clear as day. Let's implement the solution. The way that we're going to be doing this is we're going to sort the array because initially it's not sorted, and we're going to have sort of this like blueprint, which is just the sequence of numbers starting from 1 to 100. We're going to imagine this sequence of numbers, and we're going to see how well does our input array match up to that sequence, right? And we're going to be using a DQ to essentially populate using our nums, we're going to populate the DQ with the numbers at our disposal as close as possible to what we have as our blueprint, as our imaginary sequence from 0 to infinity, going up one by one. And with that, I think we are ready to start the implementation. I'm going to say L, which is just length, is equal to nums length as an i32-bit integer. I'm going to create a mutable DQ, which is going to be a collection. This is going to be a vector DQ. Oops. For those of you who don't know, a DQ, and we're also going to need a hash set, so I'm just going to include that. A DQ, as opposed to a regular vector, has the property that you can pop from the left and append to the left, whereas in a regular vector, sort of like a stack, you can only append or remove elements from the back. So we have this vector DQ new, call the constructor on that, and max occurrence. I'll explain where that goes later, or maybe you will just see. Let mutable nums. This is going to be a sorted version of our nums. I'm going to make it i32 equals nums to iter. And we're going to collect it into a hash set. And by the way, I absolutely did look up all these methods because there's no way to remember this. Look at this line. Nums The way to convert it into a hash set is there's a couple of different ways. You can do hash set from, I believe, and then have this here. But I guess the more popular way is just to collect it into a specific type, and that type is hash set with a value. I'm guessing that that's just a placeholder. Then we need to sort this array. And for n in unique arrays, unique elements, we're going to now, given that we have this unique nums, that is given that we have this DQ, which is going to be our like little attachment that is running along the, let me draw out what I'm imagining it. 2, 3, 4, 5. This is our ideal blueprint, and then we have this little DQ that is running alongside of the perfect blueprint and trying to see out of the nums, unique sorted nums, can we construct anything here? And here we would have a 2 in the case where we're looking at this one, and then we have a 3 and then a 4 and then a 5, and boom, we're good here. But in the case of the other one, let's have the 1 here. We have the 1, 2, 3, boom, 4 is missing, and then 5 and 6, and we're running along this side and trying to figure out, well, what is the maximum length, what is the maximum correct continuous length that I can create this array? What is the max continuous length of this DQ that I can create from the unique nums? I'm just going to leave that here for now. Let me actually do another one here. I'm sort of getting into what I didn't want to. These would be the 2 types of arrays. Now I get 5 and 6, missing the 4. Cool. While DQ len is greater than 0, and n minus DQ first, and we have to unwrap that wrap, because in Python, if this executes and fails, the other end doesn't fail, or it doesn't even run. But in Rust, I guess it does. So we have to unwrap it in the case where first doesn't actually exist, and it's a panic. DQ pop first, and let's see, DQ push back n, and max occurrence is equal to, now we have to essentially just do this max of this and DQ len as I32, but max doesn't exist, so we have to use standard compare. And finally, let me put this somewhere here. And finally, we will return simply the max minus the max occurrence. Okay, let's see, did I forget any parentheses? No, let's run this and hopefully it works. Hopefully it's fast. And I messed something up. Iter hash that into iter collect nums, iter collect of some type, and then the value. Oops. Hopefully no misspellings. Collections. Standard collections. Oh my gosh. First, dq len is greater than 0, and dq first unwrap. Pop first, push back, len, compare max. Come on. No method first. Found on dq. Because it's called front. It's called front, not. And this is also pop front. Push back front. Push back. Up front. First try. Just kidding. Cool. Well, at least I hope that was entertaining. Look, we're beating 50%. We're the only ones that submitted it. I'm not gonna look at that. Yeah, take a look at my Python code. Python code is way simpler, and I have a whole video on that. Rust is more complex, but about 20 times faster. Cool. Thanks for watching. Let's keep this short. See you later. Bye.